Hello everyone, today we're going to be doing Sine Law a little bit more. Before we start into the new stuff, we'll just go over the assignment from last class, starting with question number 6. Here's a picture of a pica if you're interested, basically a mountain hamster. Here's our setup for number 6. If we knew what this side length was, we could apply SOHCAHTOA, but we don't know what this side length is, so we need to do something else first. Because we know 2 out of 3 angles in this big triangle, it turns out that this angle is 127 degrees. And now that we know 2 out of 2 in this side angle pair, we can figure out what side length S is here. So we just apply Sine Law and we get 14.7. In part B, we need to figure out how far Steve is from the pica. We just do K over K, P over P. We know what angle K is, we know what side length P is, we know what angle P is, so we just need to figure out what lowercase k is. And on to part C. We have this right angle triangle. We need to figure out what this distance is. We can use regular sine if we have a right angle triangle. This is our reference angle. This is opposite. This is hypotenuse. So we can figure out W, and it turns out to be 4.3 meters. For question number 7, we can see our setup here. We have an angle here, an angle here. We can figure out the third angle this way. We need to figure out all of these side lengths. This one's already given to us. So we can start by finding side length B by using Sine Law. We know 2 out of 2 in this side angle pair. We know 1 out of 2 in this side angle pair. And here's how we do it. And then we do the same for side length A. We know 2 out of 2 again in this side angle pair and 1 out of 2 in this side angle pair. We just need to figure out what length A is. Once we know what A and B are, we can add A plus B plus C to get the total perimeter. We're going to go over question number 8 now. Charlie is in a hot air balloon above Regina, Saskatchewan. His friends David and Eva are watching from the ground. David and Eva are standing 100 feet apart, and the angle between Charlie's line of sight to the two of them is 11 degrees. Eva is 505 feet from the balloon. What is the angle of elevation of David's line of sight to the balloon? So here's our diagram. We need to figure out what this angle is. We can call that D, this side length D. This would be E, that would be lowercase e. This is capital C, this is lowercase c. We know 2 out of 2 in angle C and side length C, and we have 1 out of 2 in angle D and side length D. So we can just apply Sine Law by going sine D over D equals sine C over C, and plug in what we know. So D is what we're trying to find, angle D. We know length D is 505. We know angle C is 11, and we know side length C is 100. So we isolate for sine D, which would be 505 times sine 11 divided by 100. We can evaluate this in our calculator. Go 505 times sine 11 divided by 100, which works out to be 0.96358 and some other digits. If we want to figure out what angle D is, we need to take the inverse sine of that number, and it turns out that angle D is 74.5 degrees. Moving on to question number 9. The flagpole is stabilized using 2 guy wires. The wires are attached to the ground on opposite sides of the flagpole, 8 meters apart. The wire on the left is 4.7 meters long, and the wire on the right is 6 meters long, and is attached at an angle of elevation of 36 degrees. So part A, we need to figure out what the angle of elevation of the wire on the left is. So this one, we know 1 out of 2 in this side angle pair. We know 2 out of 2 in this side angle pair, so we can proceed with Sine Law. We can maybe label this A, that A. This one we could label as B, and C, and C. So we need to figure out what angle A is. So we go sine A over A equals sine B over B, and plug in what we know. So sine A over 6 equals sine of 36 over 4.7. I'm assuming that would be in meters. And then we just isolate for sine A. So sine A equals 6 times sine of 36 divided by 4.7, which works out to be 0.750, and so on. If we want to figure out what angle A is, we need to take the sine inverse of this number. So we go sine inverse of that number, and it turns out that angle A is 48.6 degrees. Now for part B, we need to figure out how high up the pole the wires are attached. So basically we need to find out what this distance is. We can proceed if we assume that this angle is 90 degrees. So if we assume 90 degrees, then this length is 3.52 meters. However, if we cannot assume that this angle is 90 degrees, we need to approach it a little differently. So if we take a look at this green triangle, we only know 1 out of 2 in this side angle pair. We only know 1 out of 2 in this side angle pair. And we know 0 out of 2 in this side angle pair. So in order for us to answer this question, we either need to assume that this angle is 90 degrees, or we need more information. Here's your assignment. That's it for me for today. I'll see you next time.